Ash, welcome.
Thank
Excited to have you here tonight. Let's start with introductions. Do you want to tell us a little bit about Zetta Venture Partners?
Yeah, we lay claim, which sounds like a funny claim to lay today, as being the first fund completely focused on intelligent systems. So back in 2013, we just decided essentially that in our mind, there was no point in investing in anything else. So that's what we did. Personally, just before that, I started the money side of AngelList, which is all the online fundraising and syndicates and all that sort of stuff. So got that off the ground, and obviously it's a whole business today, managing billions of dollars. But the very early parts of that, I worked with a few people at AngelList to get that up and running.
Great. So when did the fund start?
The fund started at the very end of 2013.
Okay.
And so we invested our first fund over 13, 14, 15, 16, and then we started our second fund at the start of this year.
Okay, and you focused on seed and Series A, other stages?
Yeah, we're essentially the first institution to come in. And I mean, we can talk about the specifics, but we're really interested when a company has a unique data set and they've started to show that it has some predictive value. So it can, they've run an experiment to show that it's predictive of something at a very high level of accuracy, or they've put it in front of a customer and the predictions are highly useful in a qualitative way. And that's when we start sort of wanting to work with a company, and when companies start wanting to work with us, to then turn that into like a full production tool and start selling it.
Great. And you're based in San Francisco?
San Francisco, yeah.
Okay, very good. And you invest
everywhere
in the nation?
Yeah, all over the world. Yeah. I mean, a lot of the talent in our area is in San Francisco for sure. But if they're in San Francisco, they're very tempted by lots of other things. So we've found it really great to spend a lot of time here, a lot of time up in Canada and in England as well.
Okay, very good. All right, so let's jump right in. So what's interesting to you guys? So the world of analytics, machine learning, AI, that's sort of narrow, but at the same time very wide. What are some of the key areas you find interesting?
I might sort of explain a framework we use rather than sort of jumping into we're interested in IoT security, which we are and have just invested in that space, or whatever else, industrial analytics. The way we think about it is in terms of adoption risk. So if you think of on the x-axis is time and on the y-axis is risk, it's really important to understand at what point is the state of the art in machine learning such that people can trust it to do the thing they want it to do. Because machine learning is inherently probabilistic, right? So it'll get it wrong some of the time. And that some of the time can be significant or insignificant depending on what you're trying to get it to do. And if you're trying to get it to diagnose something, if it's wrong any of the time, someone dies, and so that risk is very high. If you're getting it to put a recommendation up to buy something, if you get it wrong, a lot of the time it doesn't really matter because the downside is it's a funny recommendation, or it's like an irrelevant recommendation. There's only upside. It's a very sort of convex payoff. So to bring that down to where we focus today, I mean, you think about where we first applied AI, it was really in all the consumer domains where very, very low risk and only payoff. Again, a very convex payoff. And so it was like product recommendations, Google search, stuff like that. That was all fantastic. That sort of started happening around 10 years ago. Then you started getting applications where the AI was just additive. So a CRM where it presented leads to you that it thought might be relevant. And if that lead was great, then yeah, you've got a new sales lead. If it didn't work, you still had like a functional CRM you could use in your job. That's what we started investing in, or that's where we started, like 2013, 14, those sorts of AI-enhanced applications. Where we're really focused today is AI-centric applications, where if the AI doesn't work, the application's pretty much useless. But if it does, it has a huge payoff. So a lot of perception stuff. So computer vision is central to the application. For example, we invest in this company, Focal Systems. It has cameras going all around retail stores, and it's in real time analyzing the image feeds and figuring out what inventory is in the store at that exact moment in time, which sounds very simple, but as a retailer, that's the most important thing, right? Managing your inventory, that's how you make money. And if that fails, the computer vision models fail, it's worse than what IBM has given you as your inventory management system, which is pretty bad. But if it works, it's obviously phenomenal and gives you a whole new insight. So that's where we're really focused today, is like what we call AI-centric, and where we're starting to move into is the next level up the risk curve, where it's fully AI-enabled. So a human just couldn't do it at all. So an example of that is managing a complex system, like managing an energy distribution system with lots and lots of inputs and lots of variability on a day-to-day basis. Or a hospital is a complex system with so many different resources you're managing, whether it's medicines or people, like high-value labor, low-value labor, all at once. That's very, very hard. And so we're starting to go up the risk curve, I guess, from these sort of AI-centric applications into AI-enabled. And that is to say, what we're not spending time on are things where we don't spend any time in the consumer stuff because a lot of that data is owned by bigger companies and it's very hard to get a data advantage there. And we don't really spend time on things that have AI sort of sprinkled on top of it, because that's not very hard to do these days with a lot of the technologies that have been put out there.
Great framework, thank you. And a little bit to the last point you made, you hear some investors talk about horizontal AI versus vertical AI. So horizontal being enabling AI that targets broad use cases, vertical being industry specific. Does it matter to you? Or would you invest in a horizontal AI company? Yeah,
it matters a lot. You said this really early on, and from the very beginning of our fund, we just said we're not going to invest in anything that's horizontal. And the reason is fundamental, right? Like if you understand how to build a machine learning model, all the fun is in like tuning it for its specific purpose. And not all the fun, all the value is in doing that at an algorithmic level, but also at the data gathering level. And so that's the first thing we thought to make us only invest in vertically focused applications, because that's where you can really get ahead of everyone else by focusing on tuning a model for a very specific purpose, getting data to train a model for a very specific purpose. So that was on the one hand, like a fundamental understanding of how this stuff works, made us think you have to be vertical. On the other hand, it's very clear that with this huge shift to cloud, as we just saw, like we're still only halfway through this shift, all these massive companies that are the cloud utilities, I call them, or cloud infrastructure providers, they want to get all these machine learning workloads right onto the cloud because they're really data and compute intensive. So they have a huge incentive to give out whatever tools they can for free to get these workloads into their cloud. And it's just so hard to compete with free. My partner saw that really early. He was the first investor in Omniture, and Omniture was the first web analytics company. And halfway through Omniture's life, Google released Google Analytics for free. And that was really hard, and he went through that. And we've seen this over and over again, and so we didn't do that. Now, we have done it twice in Kaggle and Domino Data Lab. Kaggle was just sort of hard not to partner with them because they're such a core part of the data science and machine learning ecosystem. And so we were the biggest investors in Kaggle when they sold on the board there. And it was really important to us to understand where the cutting edge was, to understand data science and machine learning talent. And then Domino, which is similar to Dataiku in a way, like you've seen this, it's the tools that data scientists have available today are like what software developers had in the 80s. So there's a lot of improvement to be made there. So we have made two exceptions.
Great, thank you. Now the million or multi-million-dollar question.
Yeah.
What do you look for in an AI or machine learning investment in terms of team, in terms of data, in terms of, we talked about positioning a little bit, but the sort of the details.
Yeah. So I guess what we don't look for is traction, right? Like by the time a company has revenue and whatever else, it's sort of, one, if you think of what my job is, it's to find things that other people can't find that are valuable. And it's pretty obvious at the point where a company is earning a certain amount of revenue per month and it's growing at a certain rate. It's pretty obvious to everyone that that company's valuable. So that's not my job to look at those things. But we also just don't think it's important. We think, relatively what's more important is to have a really strong data strategy. So this gets to answering your question in a specific way. So we look for companies that have some sort of unique data asset. No one else has it. How they acquired that is very interesting, and there's a multitude of ways, and you've written about this. You can acquire data assets, but they've acquired a data asset, right? They've shown that it has some predictive value. They've run an experiment and they've shown certain level of accuracy, precision recall, whatever else. We go into a lot of detail on the experiments they run, how those experiments have changed over time, how those experiments have changed as you change the vocabulary going into the model, how they've stayed, the stability over time. Have they converged onto something that's completely wrong, or decreased accuracy over time can happen. So we look, have they got a unique data asset? Have they run experiments to show that there's some predictive accuracy? And then the market question is, predictive of what? Of something of commercial or industrial consequence, right? So can we then go and talk to a customer, and can they say to us, yes, if I could predict this in my business, it would be worth this, and therefore I'd pay that. So it's a relatively scientific process that we go through, but it's a process that, a company that is just a couple of people and has just talked to a few customers will succeed at every step of this process.
And how deep do you go precisely into the science? But do you have partners or people you work with that actually look at the technology itself in depth?
Yeah, we do it ourselves. And again, we're less focused on, can you execute to build all the features of the product that's going to be built on top of this AI engine? That's not something that we view as super risky. Like the sort of caliber of teams we're talking to, they're going to be able to do that. We ourselves just walk through the experiments. And yeah, we all have a background in this space, all three of the partners. And so we're able to do that at some level of fluency. But it's very simple, right? Like you just ask a set of good scientific process questions, and you find out really quickly.
Do you want to give a few examples from your investments of companies that have a unique or interesting data asset?
Yeah, for sure. I'll start with something that's pretty simple and you would have thought is already done, but hasn't been. It's a company called Constructor. And they give you a search box that you can put on your website, right? If you've got a media site, e-commerce site, whatever else. Now, Algolia, Elastic, all these companies do that. They make it very easy to deploy a very fast search box on your website. But the thing is, because they guarantee you that they're not going to share any data in any way with anyone, they can't really improve that search function over time in terms of the auto-suggest results and the ranking of the results once they're sort of showed on a page. Constructor pulls data across all of its customers. So it's got a bunch of e-commerce customers, media sites, and massive ones as well, like Jet.com is a customer of theirs. And it pulls all this data about what people are searching for, what typos they make, what time of day, if they're searching on mobile, do they have shorter, longer searches, what does that mean, what are they trying to find? Use all this data to figure out what people are trying to do, and then look at all the click-through rates on all these sites and provide a really, really accurate self-learning search engine. A lot of all the companies in the market today for search as a service are Alta Vista, and Constructor is Google. And so the asset they built by convincing all their customers that they need to start pulling data to beat Amazon, because they do. And that's one example of a data asset.
Great. So you've been investing in those companies for a little while now. Any lessons learned in terms of what works, but actually what doesn't work?
Yeah. Just going off that example, actually, it's a good follow-on question, because our main lesson is you've got to get customers to buy into the data network on day one. And if they don't, you should reject them as a customer. And so what I mean by that is you have your terms, and your terms are, if you use our product, we will aggregate the data, and we will build models on top of that data, and we'll share the results or the improvements. That improved model will be used across all of our customers. We're not going to share your specific customer data with another competitor of yours, but your data is going into a pool, and that pool makes the model better. So they're in your terms from day one. And your customers should either sign up to that or not. And because a lot of customers will say, well, that's scary to us. We don't want anyone seeing our data. And that's not exactly what's happening, of course. It's aggregated, anonymized, whatever else. But they might be scared by that. And some of those customers will ask you to do an on-prem private deployment, will ask you to not use their data to train anything that you do, and you need to reject those customers. Because you are not going to build a company that has any sort of moat around it, that has the world's best model, unless you get their data to do that. And this is sort of like, 10, 15 years ago, SaaS companies that went out there and customers were really scared to like do a cloud product. And so some SaaS companies compromised and did half on-prem, half SaaS customers, and they ended up having this huge cost. And for them, the problem was it's massively expensive to maintain two completely separate systems. For you as a data company or an AI company, if you don't get customers to buy into this from day one, you're going to have, firstly, you're going to be maintaining different systems, and you're not going to have everything in one cloud-based system. But secondly, your value proposition is going to go down over time compared to companies that do stick to that. So that was the main one. I mean, lots of others. Vertical integration in every sense is really key. And that's right up to the UI layer. And this is not something a lot of people are thinking about, but it's a really interesting area I call sort of interactive machine learning or interactive machine learning UI, which is how do you make interfaces that collect the data you need to go back to the very beginning of your model, right? Like putting in a standard SaaS interface on top of something that's like an intelligent system, you might get, was this prediction right or wrong? Yes, no. That's very different to sort of creating an interface where people say, okay, what about this image was accurate, or the way we labeled this image was accurate or not, and providing a really nice interface so it makes it really natural for people to give you the labels you need to make your models better and better. That's another thing. And then on the talent side, obviously talent is a question on everyone's minds in data science and machine learning. It sounds very obvious, but it's hard to do. But it's imperative to do this, which is just look beyond computer science. Look into biology, physics, econometrics, geology. Like, you see this in the winners of the Kaggle comps, right? Like the winner of the NASA Dark Matter comp, I think he was a glaciologist, studied the movement of glaciers over time. You see all the winners, the winner of the cardiology comp was at a hedge fund. So if the winners of the Kaggle comps, which are like some of the most interesting and difficult machine learning problems in the world, are not computer scientists, that should say to you that a lot of the techniques that you can use to solve these problems are not coming from computer science. They're coming from other areas that use statistical methods. So looking really far, relative to Silicon Valley mindset, really far afield into some of those disciplines to hire people has been immensely productive for companies that we work for.
Good. And shifting gears a little bit and speaking of Silicon Valley mindset, how do you think about the societal aspects of AI in terms of the impact of AI on jobs, for example?
Yeah, so I've been accused of and will self-label myself as a naive optimist here, in that I really believe in a couple of things. I mean, humans will find other things that they like doing and they can do more of, more creative tasks, whatever else. We have an insatiable need for stuff, and we'll just keep inventing stuff for our fellow humans to consume, and we'll apply ourselves creatively to invent that stuff. That's something I believe. Another thing I believe is that it's happening way slower than people think. I mean, you and I, and pretty much everyone in this room, I guess, is on the ground level here, and we see that like you can't get computers to do that much. Yeah, I don't need to give silly examples, or it's easy to tease robots because they can't speak back. But
for now.
So they can't do much. Like, it's happening a lot slower than people think. And then the third reason is, like, I'm seeing a lot of, and this is more interesting and less on the naive optimist side, but more on the constructive side, and engaging with the actual jobs debate. I'm seeing a lot of jobs being created. So we'll have early stage companies, like companies with like, less than $10 million in funding, some of them less than $5 million in funding. And they're hiring teams of 40 to 50 data labelers. Now, some of these people on these teams are, doing jobs that are a little bit menial, not necessarily. They can be pretty interesting. But some of these people on these teams they're pulling out of, one of our companies works in the auto insurance industry. So their product is you can take a photo of a car that's crashed and it'll tell you what part is broken and whether you should repair or replace it. And so they're hiring people out of insurance companies and training them to train their AI systems, and they get a pay bump, they have more interesting work, and they can see the impact of their work at scale. It's like a way more exciting, interesting job for them. So in a sense, like, I don't think people talk about job creation that much in machine learning and AI specifically. It is happening. Now, of course, you've got to consider net job creation, but I would like people to talk about that a bit more.
Great. One last question from me, and then we'll open it up to people. So I guess what's next? Where are we in the cycle of AI? This weird thing where, because it's been so hyped up, some people are starting to say it's almost already over. Other people are feeling that it's actually just getting started and it's a trend for the next 10 years. Where do you think we are?
Yeah, I think we're at a really interesting point. So if we go back to that curve I explained before, with risk and time, and you've got the consumer stuff, you've got the AI-enhanced sprinkling of AI stuff, you've got the AI-centric stuff, and then you've got the AI-enabled stuff. We're really at the start of this AI-enabled age. So that is doing things with AI that humans just cannot do. And that is things that are involved or solving problems in very, very complex systems. So they are things like energy systems, logistics systems, healthcare and food production, working with a lot of biological systems, whether it's food and agriculture or whether it's human biologics. That's where we are, where we're starting to see AI be very useful there. And if we think about, I'd like to sort of frame that in two ways. Like, why are we starting to think about that right now? Well, one, the technology is getting good enough. And it's not that, deep learning does keep getting better and better. It's more that we're getting better at putting different methods together, right? So putting Bayesian methods in with deep learning methods in with, there's a bit more attention now on probabilistic programming as its own separate thing. So we're starting to be able to have an ensemble of models that are good at different things, such that we can solve for every problem in a complex system and then put them all together. So for example, if you're trying to predict how much energy is going to be used in the grid tomorrow, we've backed a company that does this, we think better than anyone. You have to have, on the one hand, ways to understand weather, and that's very difficult, and you use certain models for that. You have to have ways to understand just historical trading data in the energy markets, and a lot of statistical analysis there. And then you have to bring all this together in a way that you can explain. So then you use Bayesian methods to work with those predictions and make predictions at different level of risk. So it's that lots of different separate fields within AI or within machine learning have come together such that we're able to solve problems in a more complete way. We don't just throw deep learning at it and it works to a point and then we're stuck. So that's one thing that's happening, which is letting us get to this point where we can solve these very complex problems. Another thing is really a moral development of people working in technology and around our resource problem, right? And so if you think of a lot of modern moral philosophy by people like Derek Parfit and whatnot, people are starting to really believe that we have a moral imperative to take care of the population as it grows, to give every incremental person in the world the same level of resources as we have everyone today. And when you think about that, that's a really hard problem, right? Because population's increasing, but resources are decreasing. And that's a really tough optimization problem. And whether you're talking about food or energy or moving things around or access to healthcare, it's an optimization problem. Well, machine learning is very good at solving optimization problems. And so, we've developed the different fields of machine learning such that we can solve these very complex problems. And I think there's a real shift in attitude among technologists and among society in general to really think about our moral imperative to distribute resources more equally. And those two things together, I think, are bringing us to this point where technologists are really starting to solve bigger societal problems with machine learning and AI, and then bringing this back down to earth, away from up in the clouds where I've been for the last 2 minutes. This means we're looking at things like food production. 50% of food is wasted between the point of production and when you eat it. We're looking at things like logistics, which is related to the food production thing. A lot of that stuff is lost in transit. And it's because we don't have the data and the sensors and everything to understand what's happening to food as it moves along the line. And we're looking at things in energy as well. So you saw DeepMind apply their technology to Google's data centers. Think about what you could do if you applied that everywhere, in buildings, in homes, and everything else. So we spend a lot of time there.
Great, thank you. We have time for maybe one question in this. One.
They're over there.
Over there, all right. Can you pass it on? Oh, thank you.
Thank you. So I hear often that data is a competitive mode for a lot of venture capitalists, right?
Mm-hmm.
That they look at data as a primary criteria
Mm-hmm.
investing. So I guess the first part of the question is how do you know that the data is actually valuable enough to create some of this power?
Mm-hmm.
And then the second question is we just saw earlier that there was, a generative approach to recreating data. So how do you know that data is not easily replicable?
Yeah.
All other technology?
That second question is a very, very good question. The first one, I think, is relatively easy to answer. Like, how do you know that it's predictive of something? You make a prediction and see if it's right. So that's what I was talking about before in terms of running experiments. So you get the model to make a prediction. So I think that your stock levels in this store are this, or I think that this car's front fender needs to be replaced, or whatever else based on an image. And then you compare that with an assessor, like an insurance assessor, or you compare that with the actual inventory in the store or whatnot, and you see if it's right. So you run experiments. So that's how you see if it's predictive of something. But the second question is really interesting right now because people are starting to realize, okay, we want to predict something, but we don't have the data set to even predict it. So how do we make that data set? A company actually out there right now has an interesting approach to this. They're called 20 billion, and they're allowing people to build models that understand human gestures. So this is picking a cup up off a table, or this is swiping something away, or whatnot. Now that data set of humans doing these actions, these very weird or idiosyncratic actions, idiosyncratic to a task, doesn't exist. And so they have this whole platform of people they call crowd actors. And instead of saying, we've got this data, let's get a machine learning model to label that data, or let's get a machine learning model to predict something based on data we already have labeled, they start with, we want to predict this, like we want to be able to say, this is a human doing this, picking something up, and then they go out to a crowd, they get the crowd to do it 100 times or 1,000 times, and then the model works after they have seen that. So that's just a really interesting approach to this, and sort of speaks to your point about like there are more generative approaches now. How do you tell if that's unique? It's just about seeing a lot of stuff, and it's about being on the cutting edge and really understanding what options there are out there for people. And a lot of it's not that exciting, right? Like I spend a lot of time figuring out how to kludge together different data sets, how to, where you can find this weird data set of like, phone numbers in a certain country, or where you can find, the car example is a good one, like where you can find a data set of 1 million crashed Dodge Rams. So it's about like searching for these data sets and working with these data sets every day, and eventually you figure out what's novel, what's out there, what's not out there. 20 billion, 20bn.com.
Great. Thank you very much, Ash. This was
Thank
terrific.
you.
Appreciate it.
Thanks for having me. Cool. Have a good one.